Chemical reactions are an important part of chemistry, and chemists classify chemical reactions. Let's look at these three classes of chemical reactions: synthesis reactions, decomposition reactions, and exchange reactions. So synthesis reactions occur when smaller molecules or atoms combine to create larger molecules. These reactions often require free energy and often have a positive delta G. These reactions only have one product. Decomposition reactions break apart larger molecules into smaller molecules. These often give off free energy and often have negative delta G. These reactions have one reactant. Exchange reactions occur, sometimes called displacement, occur when atoms or ions or group of atoms switch places. If we look at table 5.4 of the text, we can see a general reaction scheme for each reaction type. In synthesis, we have two or more reactants forming one product. In decomposition, one reactant forms two or more products. And in exchange, we have an atom or ion or group of atoms that change place. So AB plus C goes to AC plus B. C and B have switched places. B was bonded to A, and on the product side, C is bonded to A. If we look at the other exchange example, AB plus CD forms AD plus CB. So B was originally bonded to A, and on the product side, B is bonded to C. And C was originally bonded to D, and on the product side, D is now bonded to A. So atoms or ions have switched places. So on the slide now, there are four different chemical reactions. HCl plus NaOH forms NaCl plus H2O. H2 plus Br2 forms 2HBr. Br2 plus BaI2 forms BaBr2 plus I2. And 2H2O forms 2H2 plus O2. So pause the video and see if you can assign the correct reaction type to each chemical reaction. And remember, those synthesis or those reaction types are synthesis, decomposition, and exchange. So the first example, HCl plus NaOH to NaCl plus H2O, is an exchange reaction. If we look at the Cl, which is on the reactant side bonded to H, on the product side, that Cl is bonded to an Na. And if I look at Na, on the reactant side, it's bonded to OH, and that OH has actually bonded with the H to form H2O. So the first reaction is exchange. The second reaction, H2 plus Br2 to form HBr, that is a synthesis. We have two reactants forming one product. The next chemical reaction, Br2 plus BaI2 forming BaBr2 plus I2, is an exchange. Originally, the I2 is bonded to barium on the reactant side, but on the product side, I2 is no longer bonded with barium, and barium is now bonded with bromine, which was by itself on the reactant side. So bromine switched places with iodine, so this is an exchange reaction because there was a switch. And then our final example, 2H2O forming 2H2 plus O2, that is a decomposition reaction because we have one reactant forming two products.